Hi everyone, welcome to my impressions video on one of the most field in technology, the chip manufacturing and the future of computer engineering. We live in world powered by chips, from the smartphones and laptops to cars, airplanes, and even smart home device. But have even wonder why making chips is so difficult and how something smallest that in finger mail can hold billions of translators or what's next from the technology that future our digital world. In these reflections, we share my insight about technology in manufacturing chips. Okay guys, let's start. And number one, why is chips manufacturing is so complex? The process of making computer chips are also called semiconductors. Fabrications is the one of the hardest and most expensive manufacturing process in the world. In the chips begin is sons made mostly of silicons. The silicon is purified, milled, and formed into cylindrical crystal called ingots. There's are silicons into wafers, and this that serve as the base of billions of translators. But here, why is difficult? One, many illustrations. Modern chips have translators measuring in nanometers and billions of a meters. The latest chips from companies like TSMC and Intel have figures as small as nanometers. The smallest that is single virus. Extreme previous even a tiny speck of dust can ring a chips. So manufacturing must happen in ultra clean rooms where the air's 1000 time cleanings. That is hospital operating room. In complex process are reading a chips involves hundreds of steps with each wafer going to a method of processing using light, chemical, and heat. High cost in the machine use like CUV lithography system from Asian cost over $150 million each. All of these explain why only a few companies in the world can produce advanced chips. It's not just science, it's art of nano scale. And now, going to part number 2. How CPU are actually made taught a process called a photography, and the core process in the core photography is like printing and microscopic blueprint on a silicon wafer using light. Here's how it's worked in simplified steps. Number one, coating the wafer. The wafer is covered with light sensitive materials called photoresist. 2. Exposing the patterns ultraviolet or UV light is a shiny dot at mass that contains the chips. The design this light chemically changes the photoresist, leaving behind the desired pattern. Number 3, engines the exposed part are removable, creating tiny lobes and channel form translators. 4. Diffing and depositions atoms are added that modify conductivity, forming the millions or billions of translators that control electric current. 5. Laying the process is repeated dozens of times to build up multipliers, layers, or secrets, kind of like stacking our microscopic cities. Take 5. Testing and packaging. Finally, the wafer is cut into individual chips, testing the performance and packaging on device. The photolithography is so precise that modern machines use extreme ultraviolet or EUV with wavelength shortened than 15 nanometers. This allowed for extremely detailed secret patterns. The reasons your smartphone can be both powerful and compact. Now coming the part of 3. Future trends in computer engineering 2025 and beyond. And as we look towards the futures, the field of computer engineering continues to evolve faster than even. Here are 10 emerging technology that are shaping the field in 2025 and beyond. Artificial AI or artificial intelligence and machine learning. Engineers are designing faster AI optimized chips from data center and edge device. To 2. Quantum computing using qubits to perform computations that classical computer can. Neuro 3 chips. Chips modeled after the human brain to enable ultra-frequency learning and decision making. For 5G and the 5G network enable faster connectivity and the Internet of Everything. 5. Internet of Things, a variant of connected and sensor and smart device driving innovations. 6. Edge computer processing data locally rather than in distant cloud serve the for faster response. 7. Nanotechnology and the advanced materials. New materials is graphics and carbon nanotubes. Ultra silicons. 8. Cyber security hardware. Hardware base of protections becoming of necessary. 9. Augmented reality of AR and virtual reality or VR, powering immersive learning, design, and communications. Green computing focuses on sustainable chips manufacturing and energy efficiency systems. These trends show that computer engineering is just about hardware and software is about integrating to solve complex global challenges. Reflections on all this, I realize the chips manufacturing represents in the framework of human innovations, where physics, chemistry, and computer science come together to push the boundaries of possibility. In humbling to know that something as small and microchips is responsible for powerful entire industry and shaping modern civilizations. As an aspiring computer engineering is inspiring to learn more about semiconductors, AI, and advanced computers. The reflections reminded me that the future is not just about using technology. It's about understanding how to make and imagining what's unused next. In my conclusions, the chips manufacturing is not only technology achievements but also a symbol of humans enduring from the challenges of nanometers scale previous to the exciting new trends shaping our digital futures. The journey from sand to silicons continue to inspire innovation across the world. Thank you for watching my reflections. When you're enjoying this, don't forget to share. Thank you. Thank you. Thank you and goodbye.